Welcome, everyone. For today's prep, we're going to be looking at absolute convergence. And we're going to start looking at some definitions. And in particular, we're going to see how absolute convergence tells us, or we can use this to tell us when a series is convergent or divergent. So let's get to our test here. And actually, we're going to call this the absolute convergence test. So let's read through it. Suppose we have this series, sigma an, that we want to figure out if it's going to converge or diverge. And the idea behind this test is we look at this related series, sigma absolute value an. All right, so before we get to the meat of what this theorem says or what this test says, let's look at these two different, these are potentially two different series. So let's look at what they are. So we have sigma an. And let's just write out the first few terms here. So let's suppose that this starts at n equals 1 and we're going to infinity. So the very first term would be a1, and then we're adding a2 and a3 and so on. Okay, so what happens, for a general series like this, some of these terms could potentially be negative. So some of these terms, when we're just adding up terms of a sequence together to get this series, some of them might be negative. Well, when we look at this related series, the series of absolute value terms, and again, as a for instance here, we'll say our series is going from n equals 1 to infinity. What we're doing is we're still adding up these individual terms, but now we're doing the absolute value of each of them. And, we keep going. So what happens here is with this new series, so this might be a new series that we get, all of these terms here are going to be positive. So, if let's say a2 was negative in the original series, well, when we do the absolute value of that, it's going to be positive. All right, so the idea behind this is sigma an is the series that we're investigating, and negative terms, as we've seen with a lot of our previous tests, negative terms can cause us an issue. So instead, we're going to look at this related series, sigma absolute value an. And here, all of the individual terms are positive. All right, so what does the test actually say? It says if this series of absolute value terms converges, then our original series converges as well. Now, if this series of absolute value terms diverges, well, then this test is inconclusive. So we don't know. The original series might converge, might diverge, we just don't know. But this test gives us another option to deal with series that have negative terms. So if we're investigating a series that has negative terms like negative 1 raised to the power n, well, we might be able to use this test. So let's try an example. Let's look at example 1. So here we're going to determine if this series is convergent or divergent. So the sum here is from n equals 1 to infinity of negative 1 raised to the power n over n squared. Now, this is, well, we have that negative 1 raised to the power n. So some of the terms here are negative. Now, we could potentially use the alternating series test here. So this negative 1 raised to the power n, that kind of gives us that alternating piece. So we could use the alternating series test. But we're going to try investigating this with this absolute convergence test. So let's form our series of absolute value terms and look at this. So we have our original series. Let's call this sigma an. And so we have our original terms here, -1 raised to the power n over n squared. And when we form this series of absolute value terms, let's write it out. We're going to have the sum from n equals 1 to infinity, the absolute value of -1 raised to the power n over n squared. And the nice thing with an absolute value, and when we have this -1 raised to the power n, just gets canceled off. So this becomes just the sum from n equals 1 to infinity of 1 over n squared. And at this point, we know what this is. This is a p-series, and it's convergent. So this is a convergent p-series with, what's our p-value here? It's 2. And in order for a p-series to be convergent, we need our p-value to be greater than 1. Okay. So what we found here is that this series of absolute value terms is something we can, immediately recognize as convergent, a convergent p-series. So what that means is our original series has to converge as well. So since sigma absolute value an converges, sigma an converges as well. And then we just want to state which test that we're using. So we're using absolute convergence. So we'll call it the AC test. All right, so when this one works, kind of simplifies things down a little bit for us. So if we were going to do alternating series tests, there's more things to check. We would have to show that the series or the sequence, we'd have to separate off first that negative part. Then we'd have to show that the limit is equal to 0, and then show that the terms are decreasing. So with this, when this works, it works pretty well. There's not too much to show. Okay. So what we're going to be doing in class is we're going to see what happens. We're going to be looking at two definitions, absolutely convergent and conditionally convergent. And we're going to see what these two are. And we've seen series so far that fit both of these descriptions. So we'll see you there in class. Bye-bye.